Okay, you guys, in this video, we are going to go over segments and midpoint, and we'll be talking about segment addition postulate. Now, postulates are a little bit easier, I think, to accept because they're kind of backed by common sense. You can look and obviously can tell that they're true, and theorems are the ones that we have to just kind of just believe, like, okay, our geometry gods are telling us this is how it works, and we just have to kind of accept it. There's not a lot of proof behind our theorems, but in our postulates, you'll see that, okay, this does make sense by even just common sense, and we can go from there. So how I introduced this to my classroom is I started talking to them about kind of what they already knew, or connecting it to something they knew, just to kind of build their confidence in saying, yes, you actually do know segment addition postulate. We just, before geometry class, we didn't give it that fancy name. So I was talking to them and I said, okay, I want you to envision that I am designing shelves in a closet for someone. And when I said that, they were like, oh, it's going to be for LeBron. I said, okay. So we're going to use LeBron. And I am going to put shelves in his closet. Okay, so here's the closet, and I asked the class, I said, okay, well, what do I need to know if I'm going to design shelves and that cover that entire wall of the closet? And they were like, well, you need to know the measurement. You're exactly right. So we're talking like in feet, and I'm going to say 24. Every class kind of gave me a different measurement. Everybody kind of thought different lengths for his closet. Excuse me. So if the closet's 24 feet and he wants shelves all across this one wall of my closet, and I get my materials and I start building my shelf, and I only get this far, right? Let's say I covered 8 feet, of my closet. Then I asked the class, well, or we discussed, he's going to be upset because that's not what he hired me to do. He hired me to cover the entire closet, and I should have measured, right? That it was 24 feet. And he's not going to be happy with his product, right? That I did not cover shelves all the way across. So what did I need to do? Well, our discussion led to, well, you need to build more shelves. And then we talked about, well, what did I need to know? Like, what should I really pay attention to when I started building this and buying my materials? And they said, well, you need to know what the rest of the distance is, right? So I could go buy enough material and make it across. And then our discussion led to, okay, well, oops, my pen's not going to work. Then my discussion went from, okay, well, how would I know how many more feet I needed to go? All right. And so, and the idea of this is to get them, to see the simplicity of segment addition postulate. Okay. And so my goal, and of course somebody's going to finally say, well, 16. You have 16 more feet. And our discussion went, well, how did you get that? And some would say, well, I did 8 plus 16 is 24. And others said, well, I went 24 minus 8 and got my missing 16. Okay, so that's the idea of that discussion, of introducing this, was just to get them talking and thinking, so they would, again, see the simplicity here before I throw in all those fancy math words, right? Because you know how math is. We like to be fancy and sound super smart. Okay, so if you missed class, that was our discussion. And I hope you're noticing, oh yeah, 8 plus 16 is 24. It's all about a piece plus a piece equals the whole thing. So here, segments. Segments are a piece. Hope I spelled that right. It does not look like I spelled it right. Piece of a line. Well, that doesn't look right either. Okay, already had to bust out my whiteout because it's the end of the day, you guys. It's the end of the day. Okay, piece. Let me spell that a little bit better. Okay, so that is forever going to be on my YouTube now, of me having trouble spelling today. but that's okay. So a segment is a piece of a line, a piece of something, right? A part. So the distance between 2 points A and B can be written as the length of AB. Okay, so well, I should need to say segment. And the reason I say that is right now I don't have numbers to go with it. Remember, if we don't have the numbers, then we use the notation of drawing the picture above it. Pictures have the picture above, and then the numbers we don't. And we get that from counting our spaces. I always say count the car spaces in between. So there's 4 car spaces, so I know that segment AB is equal to 4. Okay, so you can see it 2 different ways like this. And we just want to be mindful of our notations. That's what makes geometry so crazy. I'm going to be honest, as a teacher, it makes it crazy to grade because I have to check all those little details. So remember, if you are just looking at the picture and you're not given any values, that's when we use the notation above. And then we don't need the notation when we're talking about just the numbers. So that's what gets our equal sign. This would get our congruent symbol. Okay. All right, leading on to congruent. Remember, congruent is our equal sign with the similar symbol above it. I always say it's a squiggly line above. Okay, so here I'm trying to read this a little bit. It says if segments, right? If they are equal, then we can say they're congruent. And we can go back and forth between them. If they're marked with some tick marks saying they're congruent, and then they give us a number or we measure, then we can say they're equal. And vice versa. If I tell you they're both, for this case, 4, then we can go on and say they're congruent. So I'm going to say if segment AB is equal to segment CD, and I'm getting this from the measurement off the line. Okay, that's why I'm not putting the picture above. I actually counted the number of spaces. But once I can prove that they're equal to each other, then I can go further and say they are both congruent to each other as well. They're both congruent because they have the same measurement. Okay, here it is. This is the main reason of this whole lesson was for us to practice segment addition postulate. Okay, again, what's that saying is I'm going to take a piece of a line or piece and another piece. Sometimes we can have 3 pieces or 4 pieces. And once I add all of those together, I get the whole thing, the whole enchilada. There you go. So keep in mind during this whole lesson, a piece plus a piece equals the whole thing. So remember, and when you start to doubt yourself or you kind of get stressed, just go back to LeBron's closet and say, okay, that was easy. So this really is as easy as I think it is. I'm just maybe doubting myself, okay? Because they do kind of look a little crazy when we add algebra to it, but you've got this, okay? So when you start feeling a little insecure, go back to our closet. All right, so in geometry, we write geometric statements. And again, that's another thing that makes geometry a little bit tricky is it's always the small details. It's not really the math that's difficult. So my geometric statement would be that segment AB plus segment BC equals segment AC. So I have a piece plus a piece equals the whole thing. I have to change colors on you guys here. My pen's not working. Okay, so let's get some examples. Here, let me get my ID. I need a straight edge. Okay, I've got my straight edge now. So let's look at our first example. I'll get brought up here. I like to do my notes with my students too because they're always first because they give me great ideas. Okay, here we go. PQ equals 9 and QR equals 28. And we're asked to find PR. Okay, 2 capital letters tells me there's 2 points, meaning it's on a line or a line segment. Okay, so the first thing in geometry when we are solving geometric problems is we want to start off with a diagram. Sometimes it's given to us, but we want to make sure all the information given is labeled, and sometimes we have to draw it ourselves. So PQR. Okay, so first step, I've got it drawn. I want to label everything given to me. They told me that PQ is 9. They told me that QR is 28, and they're asking for the whole thing. Now, right away, you're probably thinking, oh, that's super easy, Miss H. I can just add those together. I know, but remember, it's geometry, and we're all about proof, proof, proof. Okay, so our second step is to write our geometric statement. We're going to prove how we can take this geometry problem and turn it into an algebra problem, okay? So my segment addition postulate, it's addition, so it's always adding, is, well, if I add PQ plus QR, I know that should equal PR by segment addition postulate. So I can write this and I can prove it. Like, this is my reasoning right here. And we want to start doing that now, because when we get into 2-column proofs later on in the year, it'll be a little bit easier for you. Like, you're going to get used to always having your reason. I can write this because of segment addition postulate. Okay. Third step is to now make it into an algebraic expression or equation here. PQ is 9, QR is 28, and I know that that equals PR. Now I just solve it. What is that, 37? Okay. And our last step is to check it. You can always just plug that in your calculator, double check, especially when we're rushing with our mental math. Okay, let's try another one. Okay, QR equals 17 and PR equals 21, and they want us to find PQ. See how neat and pretty that is? That just makes my heart happy. I love to see beautiful math. So if you're not used to showing your work in the past, please show your work. I love to see it, and it just organizes your thoughts. It just makes you look so amazing. All right, here we go. First step is to label what we know. Sometimes it's given, sometimes it's not, but I'm going to go through here. I know QR is 17. I know PR, ooh, that's the whole thing, is 21, and they want us to find PQ. So that's my missing piece. And again, I know you guys are so smart, and you can just look at that and be like, blue, mental math, I got this. I know, but now we're practicing to be more little sophisticated mathematicians, where we're going to show every single step, do our proofs, because proofs is big in geometry, okay, and give those reasonings. Second step, geometric statement. I know by segment addition postulate that if I add these two segments, they should always equal the entire segment. Okay, now don't try to go and change it into subtraction, saying, well, I know I would subtract, so I'm going to write that. The postulate says addition, so we will write it as addition. And you're going to see your subtraction show up in just a minute. All right, go ahead and put my reasoning down by segment addition postulate. That's why I can do this. It's always about proving, being precise and detailed. I love it. Okay, I don't know PQ, so that stays PQ. But I know QR is 17, PR is 21. Do you see where your subtraction is going to come in? Subtract 17 from both sides. What is that, 4? Beautiful. Now how I can check that is, let me go ahead and add that over here, my check. What I would plug into my calculator is substitute 4 for PQ. 4 plus 17 equals 21. 21 equals 21. Check, because I like to know that I'm right. Okay, let's look at example 3. If segment EG equals 71, you notice that they use an equal sign because they give us the number. Okay, find the value of x. And the diagram's given here. So take the time, pause the video, write this down. Okay. So the first step is everything labeled? Did they give us everything? Well, they have everything here labeled, but look, they also told us EG is 71. So they did actually give us a third piece of the puzzle here. I know that the whole thing, E to G, is 71. Okay, step 1 of solving a geometric problem, your diagram. Label everything they give you, okay? Second step, our geometric statement. And again, look for your 2 pieces. Sometimes there's 3 or 4, but we're starting off. So EG, and it's addition postulate, so we're always looking for piece plus a piece equals the whole. So EF plus FG equals the whole thing, EG. And again, my reasoning, segment addition postulate. That postulate allows me to change this geometry problem into an algebraic problem, and now it's the same old stuff you've been doing for years now. Okay, substitute this in, I get 8x minus 17 plus 5x minus 3 equals 71. Now we're going to razzle-dazzle you guys with some algebra. 13x minus 17, 18, 20 minus 20 equals 71. Add 20 to both sides. 13x equals 91. Divide both sides by 13. These steps never change. X equals 7. Now, I get in a rush and I always want to put a box because my algebra brain says, oh, get X by itself, and then we're done. But you have to be careful. We have to look and say, okay, what is the question actually asking? Asking for X? Yes. Now I can put a box, and I love it when I'm done. Right? Okay, our last example, again, feel free to pause, write this down, use your IDs or some kind of ruler or straight edge, okay, make them look beautiful. This is going to help you guys that want to go into, mainly if you like art or if you want to go into some kind of construction or engineering where you're making blueprints. Teaches us to take our time and be precise. You want it to be pretty. We want our work to be pretty, okay? You don't want to take a sloppy blueprint to your boss. They're not going to hang on to that. Okay, or you, in fact, right? Okay, first step is make sure everything is labeled here. It looks like we have 2 pieces. They've told us what it is. And then they snuck a little bit more information up here in the question, right? So TV is the whole thing. And they told us it's 14x minus 8. And now everything's labeled. So let's go on to our geometric statement. Look for piece plus a piece equals a whole. So TU plus UV equals TV by segment addition postulate. Okay. Third step, algebraic expressions. Or I keep saying expressions, equations. Okay. TU is 9x plus 2 plus, because it's segment addition postulate, right? So we want the A, or we want the plus. I'm getting too tired here. Plus 5 equals the whole thing, 14x minus 8. We have our geometric statement. We have our algebraic statement. Now we're just going to razzle-dazzle with some algebra. Now, if you struggle with solving with variables on both sides, I know it gets a little confusing. Remember to take the options away. If you're just stressed and you're staring at it like, please, something just move for me so I know what to do. Remember, your goal is to get all the x's on the left, all your numbers on the right. Now, if you're confident and you can solve it your way, keep doing that. But as long as your way has work to it, I'm good with it. Okay. I did notice here I could combine my 2 and 5 just to shorten it up a little bit. Okay. Now I'm moving my 14x to the left, my 7 to the right, cross off, bring down. What is that, 5x? Ooh, that's a negative 5x. Negative 15. Divide both sides by negative 5. X equals 3. Now again, in class, you're going to have to slow me down because I always want to put a box. Yes, we found X. That's what we're always trying to look for, right? And move on. But always pause. You guys pause and say, was that what they were actually asking us to do? Or was that just a stepping stone to the answer? So when I look back up here, you're going to notice it wasn't just x. So we're not done. We're almost done, but we're not done yet. So slow down, slow me down in class and say, wait a minute. Okay, were they asking just for x or were we needing to go further? Okay, so to go further, I'm going to go back up here to TU. Segment TU, what do I know about that? TU is equal to 9x plus 2. And then we just substitute. TU equals 9, but we know what x is now. And doesn't that look familiar? Haven't we been doing that? We've been practicing substitution. There's our answer. Always blocks it in nice and pretty. Okay. Segment addition postulate. Not too bad.